Currently, one of the main tasks of supply chain management is the effective design of distribution networks. In particular, the identification of good locations for distribution centers through simulations taking into account geographical location of customers, road network, time constraints, and capacity is always difficult. Warehouses and distribution centers are important hubs in the supply network. They perform valuable functions supporting the movement of materials, storage of goods, product processing, truckload grouping, creating assortment, and completing shipments. The planning of distribution centers is a complicated task since it is a part of a very complex network, so that the methods of designing logistics and distribution centers are also subject to constant research and improvement. In order to plan the location of distribution centers, many methods of the multi-criteria decision support are used. The objective of this article is an attempt to use the analytic hierarchy process analysis to locate the distribution centers. The most general definition of a distribution center was proposed by J.J. Coyle, acknowledging that it is a post-production warehouse for finished goods intended for distribution. According to the dictionary definition, a distribution center is an organizational unit dealing with the storage of goods owned by suppliers and their distribution to customers according to the specific instructions of the goods owner. The location of each distribution center must be subject to the thorough logistics and computational analysis. It is very important, particularly because all distribution centers are places occupying very large surface areas, which require well-equipped backup facilities combined with a very good road infrastructure. The slide presents one of the many indications of the key factors for the location of a distribution center. The main principle for the construction of the distribution center is that they ought to be built in places where there is a high demand for logistics services. Therefore, choosing the best possible location is a very difficult task. Thus, enterprises ought to use the services of the best analyst who will analyze and verify the relevant factors and help make the final decision and facilitate the most efficient conduct of the whole decision-making process. In order to determine the best location for the distribution center, the methods of the multi-criteria decision support are used. For example, fuzzy set theory, p-median model, or a mathematical method that combines AHP, DEA, and linear programming. One of the most well-known methods is the hierarchic analysis of the decision-making problem AHP, which stands for Analytic Hierarchy Process, enabling the introduction of a relative scale of ratings priorities for countable and uncountable criteria. The creator of the AHP method was Satie, and the method itself was developed in the early 1970s. The method consists of 4 successive stages. The first stage consists of the identification of the most important criteria, subcriteria, and their options, if such occur. The second stage consists of the identification of the relationships between individual criteria. For this purpose, the matrices that enable the comparison of the criteria in pairs are created. The determination of the value of the matrix is possible by calculating the quotient of each of the weights by the sum of these weights in the given column. In the third stage, the analysis of the matrix consistency takes place. This means that the degree of consistency of information given in the second stage is verified. The fourth stage is the calculation of the preference index for all the elements of the set of acceptable solutions occurring in the set. The index is calculated according to the formula below. The final result of the use of the AHP method is the ranking list, created on the basis of preference indices within the range 0 to 1. The use of the AHP analysis allows for the presentation of the set of acceptable solutions in an orderly manner, which allows for easier identification of the best decision. The final decision is always made by the decision maker. In this work, the AHP method was used to select the best location for the distribution center in the theoretical example. The first stage is the analysis of the conditions which are linked to the decision-making process and the entities which participate in this process. This stage is to indicate appropriate options as well as decision-making factors. Exemplary criteria and subcriteria, which will determine the selection of the center location, are presented in Table 2. To begin with, let's look at the social criteria. Building a new distribution center arouses widespread public interest. This type of investment is accompanied by protests and objections among local residents. This is all due to the fact that they fear the possibility of disruption of orders, changes in landscape, environmental pollution, or increased traffic on roads. Secondly, spatial criteria. The primary issue relates to the distance between the distribution center and the distance from the other equally important elements of the spatial development. Thirdly, economic criteria. The economic factor plays a major role during the realization of each investment project. The criteria in this factor include capital expenditure as well as future envisaged projects. Moving on to environmental criteria. New distribution centers may increase an environmental pollution in the said area. Finally, legal criteria. Investments related to the construction of logistics and distribution centers are a subject of a wide range of national and international legal regulations. For the purposes of the pairwise comparison of the criteria, the fundamental 9-point SATI scale was used. Individual results of subsequent comparisons in pairs are presented in the form of a square matrix of comparison depicted in Table 3. The weights of the considered criteria were determined by the calculations made in the spreadsheet of Microsoft Excel software. Following the calculations, it was found that 3 criteria had the same evaluation weight, amounting to 0.250. Spatial, social, economic, and environmental criteria had the strongest interaction. Legal and spatial criteria had the weight of 0.125. In relation to the obtained level of criteria, the evaluation of the coherence of the comparison matrix was carried out. On the basis of the results presented in Table 4, it can be concluded that total consistency in expressing opinions was maintained. In the case of the practical use of the AHP method, it would be necessary to carry out appropriate calculations at lower levels in the developed hierarchical model. These calculations would consist of the pairwise comparisons of subcriteria in relation to the subsequent criteria, and also the pairwise comparison of options in terms of elements which are located at higher levels. The implementation of these options would allow the indication of the final option of the ranking, which would be linked to the determination of the best location for the construction of the distribution center. The computational algorithm of the AHP method, along with the results found thanks to it, may serve as the justification for the selection of an option. On the basis of the theoretical research conducted in the article, it can be concluded that there is no single decisive factor and criterion which would directly indicate a specific location for the logistics center. The success of the investment is usually determined by a range of factors, which are closely correlated. Thank you very much for your time and attention.